Great. So here are some questions from section 6.1. And for section 6.2, I'm going to try to explain just a little bit more than the book says, so that you can understand why we choose sine and cosine and all of the other things. To 190. There you go. So this is some problems from 6.1. So number one, say I want to convert 36 degrees into radians. Number two, I want to convert, say, 7 pi over 3 into degrees. Number three, I want to find a coterminal angle between 0 and 2 pi for the angle, say, 22 pi over let me put 23 pi over 4. 23 pi over 4. That's good. Number four, say, right, I want to find a coterminal angle between 0 degrees and 360 degrees for the angle, put negative 800 degrees. Number five, say for this one, let's write it this way: find the length of the arc that subtends a central angle of measured, say, 40 degrees in a circle of radius 12 meters. And one more, number 6. Say that a sector of a circle has a central angle of 30 degrees. Find the area of the sector if the radius of the circle is, say, 6 feet, just like that. So these are the type of questions that we are looking forward to answering in 6.1. I told you that coterminal is a good way to locate angles that have the same terminal and the same ending, right? And it will be easier for us to use angles that are between 0 and 2 pi rather than outside of this interval. We have a better angle later on. We call that a reference angle. Every angle will have a reference angle, right? And we will try to exploit what a reference angle is, and but we have to be careful. Remember the little chart that you use, all students take calculus, right? Where sine and cosine and tangent are positive. So yeah, so that is referring to you using a reference angle, right? So for that, we're gonna talk more about that maybe today or tomorrow. Okay, let's start from the first one, right? Okay, and we move down from here. Okay, there we go. Yeah, I'll scroll upwards as we go on. So convert 36 degrees into radians. So to convert from, right, 36 degrees into radians, we multiply this by something that has degrees on the bottom, right? So we have 180 degrees on the bottom, and what will go on top? Pi. By having these degrees here is a unit of measure, right? Measuring an angle. And the degrees will cancel out, and so we are going to have 36 divided by 180 times pi. How can I simplify 36 over 180?
36 by itself.
So maybe divide it by 6 first, right? So divide 36 by 6, that's going to be? Yeah, and then 6 over 30. But we can still simplify this a little bit more, right? Yeah, and then you notice that maybe we could have divided everything by 36, right? So this would have been 1 over 5 pi. And you may express it like pi over 5. That's also as well. That's good. This is good, and this is good. They're both good.
I had a question from the homework yesterday. It said like 3 radians. But how can you get just 3 without pi? I thought.
Yeah. So if you have, I will try to write that for number 2.
Okay.
What if you only had a number like 3 and you have to convert this into degrees, and what do we do? Yeah.
You have pi, then pi.
Yeah. So we'll see here. So pi in this case, it's the actual number pi, like 3 points, right? 1415 and so yeah. So we will just try to understand that this is just measuring something, right? And in terms of pi, but if it doesn't have pi in it, we can still figure that out. Yeah. So let's see. So here is. I'll try to put 2 problems that are relevant to that, right? Yeah. Ouch. That's too much. There you go. So for number 2, convert 7 pi divided by 3 into degrees. So for this one, we're going to start off with 7 pi over 3. And we're going to multiply something that has a pi on the bottom, right? And on the top will be 180 degrees, right? And so that way the pi's will cancel out, right? And we're going to be left with 7. Yeah, let me write it like this. 7 times 180 degrees divided by 3. But it's easier just to look at the 180 divided by 3 first, right? 180 divided by 3, this simplifies to?
60
yeah. So 7 times 60 degrees over 1, right? So that's just going to be 7 times 60, that's 420. And this will be in degrees, right? Yeah. Let me see if I can change the color. Yeah, let's see. Yeah, there we go. But so here's an extra question, right? Additional question. And yes, so number 1, convert 5 radians into degrees. So we do something very similar to what we did here. 5 radians, we're going to multiply this by pi on the bottom and 180 degrees on the top. So what is this going to be? Well, 5 times 180, right? That's going to be like 900, I think. 900 degrees divided by, and we leave it like that. and that's the answer for it. Yeah. And so the 5 doesn't have a pi, so it won't cancel out in this case. But we still do the same thing. We multiply with the same unit conversion.
Number 1, do we also put radians?
It's your choice to put radians, but you don't have to. Yeah. Mm-hmm.
Pi over 5 is the answer, and pi over 5 radians.
Yeah, that will be more clear if you put units, but that's fine without it. Yeah.
So just having a pi there, doesn't it mean that it's already in radians?
Yes. And so the angles can be measured either in degrees, and that will have the units. If it doesn't have degrees, that means the answer will be left in radians. Yeah. Yeah. And in the future, I told you after calculus, any angle that you see will be given to you in radians. It's like it has no they won't put radians next to it. You will assume that it's not degrees. Yeah. Mm-hmm. And these values right here, I'm gonna show you a picture or a diagram afterwards. And you will see that every point in a circle can be located by just its angle value, right? And that angle value becomes a very, very nice what we call later on a parameter. And but I will show you a diagram afterwards. So number 2, right? So convert 5 radians into degrees. We did that, and then here find the circumference of a circle with radius r equals to, say, 2 over pi. 2 over pi. So find the circumference of a circle with radius r equals 2 over pi. And find the circumference of a circle with radius r equals 2 over pi. So what is the circumference equal to?
2 pi r.
But we know that r here is
2 over pi.
2 over pi, and this will just equal to
4.
Yeah, 4. So the circumference doesn't have to depend on pi either, right? It could be that you measure the radius of this and equal to 2 over pi, and the circumference is just 4 without any pi's in it whatsoever. Mm-hmm. So that's perfectly fine to see something like that as well. So those are 2 examples. One where you have pi in the degrees answered, and the second one where you have no pi in the usual places that you will find pi, like circumference and areas. You can nullify that. For number 3, let me move this out of the way. There we go. This should be good enough. Find a coterminal angle between 0 and 2 pi for the angle of 23 pi over 4. So we're going to take away what? Yeah, 2 pi's, right? Take away 2 pi's. So if you're wondering, right, it's easier just to think about it like this. If we measure angles of 2 pi, right, we're going to have 2 pi. But what is 2 pi equal to? Well, you want to have the same denominator as the other one. So this is going to be 8 pi over 4. What about 4 pi? That's going to be 16th, right? Is it? Yeah. 16 pi over, over 4. Right? Yeah. And if you take another one out, right? Say 8 pi, right? 6 pi, sorry. 6 pi. And you multiply this by 4 over 4, that's going to be 24 pi over 4. That's too much. This is too much to take 6 pi out. So what do we need to take out? We just need to take out 16 pi over 4, right? And is it not a tricky question? But you can get the answer right away. The answer should be like something in terms of pi over 4 and so on, right? It could be 1 pi over 4, like it could be 2 pi over 4, which is pi over 2, 3 pi over 4, or anything like that, right? But it has to be in terms of pi over 4. Let's see. So the answer that we're going to get here will be 23 pi over 4. If we take 2 pi out, it's not good enough, right? We can take more. So we're going to take out 4 pi. If we take 6 pi, it's too much because we're taking out 24 pi over 4. That's going to give us a negative answer, right? So we're just going to take enough. So minus 4 pi. But 4 pi, again, this is 23 pi over 4 minus 16 pi over 4. What is that going to give me? 7, right? 7 pi over 4. And that will be my answer. If I take another 2 pi, I'm going to have a negative pi over 4, and that's not good. So the answer will be just this part right here. So either you add 2 pi's or you take away 2 pi's. In this case, we took away 2 pi. We could have taken another 2 pi. That's a total of 4 pi. If we take another 2 pi, 6 pi, that will be way too much. That will put us in negative place. Mm-hmm.
Much easier. So using the method that you taught us yesterday, I will solve this problem like this: 22 pi over 4 plus pi over 4, and the answer will be, the terminal angle will be pi over 4.
Yeah. Yeah.
That's even more simple. The way I just.
Yeah, you see it that way, other people see it this way. So let me write what you pointed out, right? So 23 pi over 4, we're gonna write this as, so say that we write this as 20. Let's see. Let's write 16 pi over 4, right? Plus what? Plus 7 pi over 4, like this. That means that 16 pi over 4 is representing 4 pi, right? Plus 7 pi over 4. You see why we can cancel out the 4 pi's, right? Because that's just coiling on the same circle again and again 2 times. So the answer is just going to be 7 pi over 4. We undo those. So the little diagram here maybe will look like this. Let me see. Let's put this smaller. Maybe a little diagram here will look like this. So here is that x and y, and we really mean the x and y axis. They're not creating a separate axis. We still are on the same xy axis. And here we're gonna go, it's positive, so it's gonna go counterclockwise. Once, twice, that's 4 pi, and we're still going to have 7 pi over 4, and I believe it's gonna leave us somewhere over here. That's where it's going to lead us up to. There you go. That's where we can just say, hey, you could have just done this, right? Rather than going around the circle twice, you could have just done that, right? Instead of going on the middle one two times, that's a waste of time. It's like going to your friend's party and then you see somebody that you don't want to meet, and then you just drive through and then come back because you really need to go to the party. Anyways, yeah. So for number 4. Yeah, your question? Yeah, but that's way too much work, and plus you don't want to get used to degrees. If they don't give you the angle in degrees, you don't want to do the conversion back again and again. It's too much work. Yeah. So it's just, if they give it to you in degrees, just get used to it. If they give it to you in radians, get used to that as well. Yeah. Don't do the conversion like that.
So do we really need to know how to graph like that?
No, it's just helping you visualize that you just went around the circle 2 times and then extra 7 pi over 4. So you will need to know where in this quadrant is 7 pi over 4. By this I'm indicating it's in the 3rd quadrant. Yeah. But for this one, it's just trying to help you visualize. Hey, you just went around the circle twice for no reason. You could have just gone a 7 pi over 4 to begin with. Yeah. And later will be helpful because, again, if you're trying to find sine of 23 pi over 4, that's just going to be sine of 7 pi over 4. It cancels all of that coiling on itself, right? So number 4, for this one, and not just for sine, it's for any trigonometric function. So for number 4, find a coterminal angle between 0 degrees and 360 degrees. So for this one, we're going to start off with negative 800 degrees. And what do we do for this one? We add 360 to this. So what would you get when you add 360 degrees? Negative 440, right? But that's not good enough, right? We're going to have to add another 360 degrees, and what is that going to give me? Negative 8, and that's not good enough, right? You have to add another 360 degrees.
Can I add 180?
No, you have to add the complete circular part. Like if you only add 180, then you're not adding a complete circle. You have to add by complete circles and 360 degrees. Otherwise, if you have an angle here, and say this one right here. You see, if I add from here, if I add one whole circle, I come back to the same angle, right? But if I add 180 only, that's going to put me in a spot like this one right here. But that's not going to give me the same ending for that. So we only add or subtract 360, right? So what is this going to give me when I add 280 degrees, right? And this is fine. This is an angle between 0 degrees and 360 degrees. If you think about this, right? We started with negative 800 degrees. How much did we needed to add? So 360 plus 360 plus 360, 3 times 360 degrees, right? And that's where this placed us in 280 degrees. So if you are thinking about this as a diagram, right, which is not required. So the negative tells you that you went clockwise, right? Yeah, clockwise. So how many times you went on the circle? So this is once, twice, 3 times plus what was it? I think it's too much, right? So
negative
80. So let's see. So you went once, right? You went twice. Yeah, and then negative 80. So that's just going to put you somewhere over here, right? Somewhere over here. And what we found now is this angle here, going forward, right, in the positive direction. And what was the measure of that angle? 280. So 270 is right under the negative y-axis, and this is just 10 degrees beyond that, right? But just to see that they have the same terminal line or ray. What about number 5, right? What's the formula for number 5? So the length of the arc that subtends a central angle of measure 40 degrees in a circle of radius 12 meters, right?
Well, S equals theta times R.
S equals R times theta, yeah, perfect. And the only thing that I told you yesterday when I wrote it out is that theta should be measured in radians. So you have 40 degrees, you have to convert that into radians. So let's see, S is going to be R, the radius for this one is 12 meters, and theta is 40, but this is in degrees. We have to multiply this by pi over 180 degrees, just because we have to measure this in radians. So we are going to have, I think the degrees cancels out and the zeros cancels out, right? And can we simplify the say 4 and 1/18th? I think we can, right? Something like that.
Yeah, 2 and 9.
Yeah. So let me write it like this: 12 times, and then 4 times pi over 18th, right? And then we can simplify it like this: 4 divided by 2 is 2, and this will be 9th, and we can even simplify more than that, right?
3.
So 12 times 2 times pi over 9th, and 12 and 9 they share 3, right? So this will be 4 and
3.
Yeah. But anyways, simplifying everything here will give you 8 pi over 3. That'll be the length of the arc. And you can put this in the calculator to know how much these will measure, right, in unit length. And what will be the units for this arc length? The units for this one will be in meters. Meters, yeah. These would be measured in meters. Meters. Because that's the units that the radius is measured in, right? What about number 6? What will be the formula for number 6? The area. Yeah, times theta. Yeah. And we got those formulas from proportions, ratios, right? And again, we have the same idea for this one. The area will be 1/2. The radius for this one is 6 feet squared. Theta in this case is 30, but we have to measure this in radians, so we multiply this by pi over 180. pi over 180. And we can simplify this, right? So this is going to be 1/2 36, and 30 degrees divided by 180 degrees, you can simplify that into 1 over 6. So this guy is just going to be 1 pi over 6. So when you simplify all of this, 36 divided by 6, right? So this will be 6, this will be 1. What is this going to simplify to? 3 pi. And what will be the units for this area?
Feet squared.
Feet squared. Whatever the units for the radius, right, is, and this will just be squared. So feet squared. Yeah, there you go. Those are going to be the units. You care for the units, not in math classes, right? But in physics, everything should have a unit, right? And
If I don't put feet square, they can take off a point.
not in math classes. Not in math classes.
On the final.
No, not in the math class. In the physics class, they would care, but not in a math class. When you go into a science class, they do care, make a big deal out of units, because having a 1 meter and having a 1 meter squared, those are completely different things, right? But in mathematics, we just wouldn't care about units, and it's fine with that, So.
So, Michael, how do you get like this formula, area, formula?
How do we get it? So the idea for this one, I'm glad you asked. So we have a circle. Let me get this out. We have a circle, right? And what we want is a pi piece from this circle. So start from the center and go out this way, go out that way, and this is the area of the piece that we want, right? Just that guy over there, this one. So we have to be very creative on what the area of that is going to be. And what we do, we start off with labeling this as theta. We call this the central angle. And if we want the area for that little sector, right? The area for that sector, let me see. Let me put this in darker color. If we want the area for that sector, we do this proportion. The ratio for this one, was this. The area of sector divided by the area of the circle will equal to, so that's the area. Now we have theta, the angle. This will equal to the angle of sector. That angle is what we're calling theta, the little angle for that, divided by the angle of the entire circle, right? Angle of circle, or in a circle, that would be better. But what would be the area of a sector? That is what we are interested on, the area of the sector. And the area of a circle is just going to be pi r squared. The angle of the sector is what we're calling here theta. So measured in radians, right? Radians. And the angle here on the bottom, the angle in the circle, the angles for that one will be 360 degrees, but we want to keep radians consistent, so we divide this by 2 pi. And now multiply both sides by pi r squared. And you get that area of the sector is equal to 1/2 r squared times theta. So this is the formula. So let me just box this. This is that, and this is how we got the formula for that. This only works if you have a section of the circle like this. What if it's not a perfect circle? What if it's curvy around it? Then we use polar coordinates. We use calculus, right? We use calculus to figure it out for areas where it's not a perfect circle. It's curved, but not a perfect circle, right? And have you seen this right here? This is like, if you have a little triangle in here, and there's a smaller triangle here, right? And let's put some A, B, C, and D. You also come up with a ratio between these, right? A ratio like this one will look like, hey, there's a small triangle, there's a big triangle, right? Yeah, so C divided by D will equal to, so C is the height of the little triangle to the height of the big triangle. It will be the length A of the little triangle divided by, yeah, A plus B, right? Like this, yeah. So this is like similar to that, but this is in terms of a section of a circle, yeah. So this is like similar triangles. This is a proportion that will allow us to figure it out, the section, the area of the section that we want, right, or the sector in this case, right? But it's fine. Okay. Yes.
So I think, like, for example, from the homework yesterday, there's like some problem. They give you like the area and the region. They ask you like to find the radius. Like how do you do that?
Sure. Do you want me to look at a homework problem? Yeah, I can look at a homework problem if you want me to. Here.
Yeah.
So what section was that?
6
Yeah. So let's see. Yeah. So it should be something like this. So do you remember which problem? So this is the booklet. So we have 13th, 14th, 15th, 16th, 17th, 18th, 19th, 19? The 20?
Yeah, 20.
20? Okay. 20? Okay. So let me just copy this. Ouch. Here. There we go. And now let me go back. And here we are. This is from homework, right? This is section 6.1 homework, problem number 20. So the area of a circle is 600 meters squared. Find the area of a sector of this circle that subtends a central angle. The area.
They use an equation.
Yeah.
And this chuck an area.
So let's try to see if these make sense, right? So the area of a circle, what is the formula for the area of a circle? Pi r squared, and they're telling you that this is equal to 600. So you divide by pi, and r squared will be 600 divided by, and then that means that r will be, you have plus and minus, but the radius is always positive, right? So the square root of, yeah, over pi. So that is the radius. So that's a plus. Now we also have this right here, that yeah. So the area of a sector. Find the area of a sector of this.
Any angle. Right?
Yeah. So subtends a central angle, right?
So
And
pick any angle.
yeah. So let's call this angle here, right? Let's call this theta, right? In radians, right? And we have this formula for it. We have that the area of the sector is equal to 1/2 r squared times theta, where theta is supposed to be a central angle, right? And they didn't give us a central angle, so you just assume that it's theta. So this is going to give us 1/2. What do we know about r?
600 over
Yeah,
5.
so r squared is 600 over pi, right? I don't need to, r squared is already that, right? So I just plugged into this, and times theta, right? So this is going to be 300 over pi times theta, where theta is supposed to be any central angle, yeah.
Okay, so you didn't I just plugged in an angle.
Yeah, so because different theta values will give it different, right? So this guy here will be the area of the sector with central angle theta, like that. But maybe if they gave you a angle theta, maybe this would have been better, right? More easy. In the book they give you 3 radians, just 3. Yeah, I think maybe I typed it and I forgot to put 3. Yeah, but it's a question in the book. in the book. Yeah.
There
But
was one question that just said statement.
Oh, probably that's the typo as well.
Like this.
Number 19? Yeah.
Yeah,
So yeah, probably, yeah. Yeah. But so these are the questions that we're focusing on, these ones, right? So that if that makes sense, that's fine. Yeah. Okay, so for 6.2 no. Section 6.2. This section is called trigonometry of right triangles. Right triangles. And imagine I give you a right triangle. So given a right triangle, so imagine something like this, and I can draw like right triangles really fast. There you go. Yeah, there you go. So imagine this is a right triangle. We should know that the longest side of this, right, is gonna be the hypotenuse of it. Yeah. So let's call it hypotenuse. Hypotenuse. Let's see. There we go. And the other two sides, it doesn't matter what they are. We're gonna call them lengths, right? But imagine I give you an angle. It doesn't have to be the base angle, right? It could be the other angle up there. But let's give you this angle here at the base. Let's call this theta. I could have easily chosen the other angle, right? But it's fine. The side that is closest to this angle here, this side right here on the bottom, is going to be the adjacent side, right? We're going to call this the adjacent side. And the one that is furthest from it, right? We're going to call that the opposite side. Opposite. And we are going to define 6 trigonometric identities, right? Later we're going to call them functions, and I will show you what they do, right, in a second. So here, the first one will be sine. How do we define sine theta? Yeah, the opposite for this one will be opposite over hypotenuse, yeah. Ouch. And number 2, we're going to have cosine. And cosine will be defined as adjacent over hypotenuse. And number 3, tangent theta. Tangent will be opposite, over adjacent. Or you can define this as sine over. Like that. That will work. And then we have the reciprocals of these guys, right? So the ones on the left are the usual. These are common. These are useful. Well, all of them are useful, but these are more useful. The other ones are less useful. Number 4, sorry, will be, let's start in the same order, the reciprocals of them, right? So the first one will be cosecant of theta. That is going to be the reciprocal of sine, so it will be 1 over. So this is just going to be the reciprocal of what it is, so it's going to be hypotenuse, right? Over, opposite, like this. Then, number 5 will be secant, and that's just going to be 1 over cosine. And this guy here is going to be hypotenuse over adjacent. And number 6, this will be cotangent. And cotangent is going to be 1 over tangent theta, you can also think of this as cosine theta divided by sine theta, and this is going to be adjacent, right, over opposite. Before we continue with this, right, I want to show you something that I think if you understand this, I think it will be really nice. If not, then later on you're going to see it again. So for now, is how do you know a triangle is a right triangle? If it has one of the angles to be 90 degrees, yeah. So no, but the easiest way to think about it at this moment is that one of the angles should be 90 degrees, right? That's the easiest way to think about it. Later on, you're going to say, well, how do we know two sides create a 90-degree angle? You're going to test it out by doing the Pythagorean theorem, right? To see if it satisfies the Pythagorean theorem. If it does, then it will be a right triangle. Later on, that's not good enough. You're going to say, we want an easier way to do this, and we use vectors in it. And we do operations in vectors, and it will be very easy to check whether two sides will be perpendicular or not, right? Like create a 90-degree angle or not. So here is what I wanted to show you. So in the future, suppose that you have a unit circle. Giving a unit circle, the unit circle, centered at the origin. So I'm going to draw it, and then we're going to think of this as a very, very important thing. Yeah. So here is what we have, right? A unit circle. Why do you think we call it a unit circle? Because because the radius for this one will be 1, right? We just want that to be the most elementary circle. So the radius for this one will be 1, is 1, will be -1 and -1. When I say 1, I mean the intercepts like this, right? These intercepts. Suppose that you want to locate a point on it, any point on it. So I'm going to start off with this one right here. Let's call this point P. This will be a point of having two specific coordinates, an x coordinate and a y coordinate. What will be the equation of this circle? The equation for this circle. What will be that equation for this circle? So we learned about circles before, right? What is the general formula for a circle? X minus
plus 1.
Yeah, well, x minus h, right? Plus equals r squared. But because I'm telling you that this is a unit circle, the radius will be 1. And what is the center for this one?
0.
The origin. So this equation here will just be x squared plus y squared equals to 1. So just know that these will be the equation. This equation is what we call a Cartesian equation, because it just tells you the x and y relationship, right? An equation.
If r was square root of 32, right?
Mm-hmm.
Then my radius would be just 32.
R squared will just be 32.
Nah, like right now the center is 0, 0, right? And the radius is 1.
Mm-hmm.
Like, if r was square root of 32, then the radius would be just 32.
No, but you're saying this: if r was equal to the square root of 32,
Yes.
then the radius is the square root of 32.
Nah.
That's what you're saying. If r equals the square root of 32, then that's the radius. You mean r squared?
Yeah.
Or maybe if r equals this, yeah, then r squared will be 32. Yeah.
And what if the r was 16?
Then r squared will be 16 squared, right? Yeah.
That's not the program.
Yeah, it's fine. So let's take a look at these, right? And imagine that we have a point on the unit circle. What I'm going to do is I'm going to draw two rays, right? Very important rays. And the first ray will go like this. From the center of the circle to the point, any point on the circle of x, y. What will be the distance between the center and that? Because the radius is 1. So great. Now I'm going to draw this one right here. A perpendicular guy down here. Why will this angle here be 90 degrees on the corner here?
We're making it 90.
Yeah, we just drawing a line parallel to the y-axis, and the bottom one is a line on the x-axis. This will create a 90 degree. So we create a little triangle. The bottom part of this one, and let me know if this makes sense or not. It's like really nice, but if you don't get it, how should we label this? That's x. That's the x coordinate of the point P. That's it. So what about this one right here? The little height for this one. This will be
That's
y. And that's how we are going to get the point x, y. But what we're saying here is, if this guy was theta, right there, then we get this right here. Number one, we're going to get the sine theta will equal to, right, opposite over hypotenuse, but the opposite will be y over
1.
yeah, y over 1. So that tells me this, that y is equal to sine theta. In other words, the sine theta will just give me the height of this point right here. What about number 2, the cosine theta? Yeah, this will be adjacent over hypotenuse, and that will be x over 1. So that will tell me that x is equal to cosine theta. So if I were to look at the same equation that I have up there with a different understanding now, I can do this now. I say, well, we say that x will just be cosine theta and y will be sine theta. So that equation gives me this equation here, right? Cosine squared theta plus sine squared theta equals to 1. That's where this one is born, right? This you have seen this before. Eh? So this is a really, really important one, and it comes from a unit circle and connecting this. More than that, we are saying, what if we are plotting points, right? What if, and this is you like going like this guy over here. Let's see. Yeah, what if you call a point in general so a point will be this x, y, right? But if you're calling a point x, y equals to cosine theta, sine theta, what if you decide to do that? Say that x is always going to be cosine theta and y will be sine theta. They're going to create a unit circle. That's what we get out of that. So let's go to Desmos, right? And what Desmos is going to do is, let's go to Desmos. Here. That's where we graph the things, right? Here. And we're going to say, I want points x, y. But what is x going to be? Cosine theta. So cosine. And does he understand what theta is? He should, right? Theta. There we go. Comma. And what should y be equal to? Sine theta. And why are we expecting this to create? A unit circle. Because this will tell you a point that lies on the unit circle. So this will be theta. Theta. There we go. And there we go. And all we have to do is, I don't think he understands what theta is. So instead, I'm going to say, instead of theta, I'm going to call it t. T. T, I told you that t stands for time. But in our case, t is going to stand for the angle. And we start from the positive x-axis, and if it's positive, it's going to go counterclockwise. If it's negative, it's going to go clockwise, right? So here, t, and this is going to be defined from 0, right? and everything is in radians now, all the way to 2 pi. So that's going to be 2 times pi. There you go. And what is this going to create? A unit circle. And you can redefine this. T is a parameter, and what I do is I'm going to redefine the same thing, but I'm going to call it something different. Let's see. Can I copy this? No. So I'm going to do this. Cosine. So x is going to equal to cosine, but instead of cosine. There you go. Instead of t, I'm going to call it s. When we use t in mathematics, is most likely creating a parameter. When I use a variable, another variable that is not t or x or y or z, like s for example, what it will create is a slider. The slider will allow me to play things, like what if I manipulate s to be a range of values, and then what it does, it runs those values. It doesn't tell a, like this one right here. So we'll see what it does, right? So this one, comma, sine theta, let's see, or t in this case, s, and there you go. And we're going to say that this one will go from 0, all the way to 2 pi. And the step size of this one, let's put 0.01, and we're going to play this. So what this is going to do is going to tell me, right, a point on it, like this. It's hard to see it, but let's see. Can this be stopped? Yeah. Let's see. There you go. So it will tell you a point on it, and when I play this, it tells you when it goes backwards, it goes in what direction. When it goes forward, it goes in a counterclockwise direction, right? But it tells you a point on it. Yeah, and you can label that point like this, right? Like that, it's a coordinate point. But it just tells you how it's moving on it. What will happen if s is replaced with 2 times s? What you are doing is you're manipulating the slider and multiplying the slider by a factor of 2. What do you think that's going to do? If you replace s with not s but 2 times s, right?
It's gonna go faster.
Yeah, it's going to go faster. It's supposed, you see? It's going to go much faster. Yeah, and it's going to go around the circle.
Twice.
Yeah, twice, because it's traveling faster. It's going to get to cover more stuff. Yeah, but you get an idea that you can do this as well. Yeah, and well, that's just the very basics of this. We build structures like this one in 3D, like cylinders, and you see the thing creating the shape of a cylinder and be building up this. So all you have to do is create a new axis coming out of the window, and this axis is separate from all of this. So we create helixes, right? We create other shapes on it. But anyways, that is for later on. For now, let's go back to right triangles, right? Right triangles. So these are angles that are really important. And we talked about these last time. So I'm going to create the little table that we did last time. Ouch. And in this table, we're going to put the values of these trigonometric functions that we just talked about. So here, so this is going to be angles. What are some of these important angles? Let's talk about 0, right? And I'm going to write them in both radians and degrees. So 0. This is good. So 0, 0. Let me see. If you remember what they were, so let's see, 0. The next one was 30 degrees, right?
30,
Yeah. So these in degrees, 30 degrees. Then 45 degrees, right? Then
69.
yeah, 60 degrees. 90 degrees.
40.
Yeah. then 180 degrees, 270, right? And then 360, right? 360 is the same thing as 0, right? Because you went back around the circle. You came back from the beginning to the beginning, right? So now, in radians now, these degrees in radians are going to be 30 degrees is going to be pi over 6. 45 degrees will be pi over
4.
Yeah, 60 is going to be pi over 3. 90 degrees is pi over 2. 180 is pi. That's where we get just the conversion unit, right? 270 is, yep, and 360 is 2 pi, like this. In radians, 2 pi is about 6 point something, right? I think 6.28, right? Because that's the value of pi is close to 3.14 and so on, right? Yeah. So let's put some trigonometric functions here. Let's start off with the simplest one, sine theta. And we're going to fill up the table like this. I think it's supposed to stop somewhere. Okay. Let's stop right here. Okay. Let's start with sine theta. What is sine of 0 degrees? 0. Yeah. And what I'm going to do here is I'm going to waste a little bit of time. I'm going to put everything like this. I'm gonna say this is 0, but I'm gonna put a space to tell you like a way to remember these, right? What about sine of 30 degrees? 1/2. But I'm leaving a space so I can show you something, right? 45 degrees, that will be 1 over radical 2, or you can think about this as radical 2 over 2. Then 60 degrees, that's going to be radical 3 over 2. Sine of 90 degrees will be 1. Right? Sine of 180 degrees,
0.
Yeah, 0.
So how do you remember this?
Yeah, I will tell you that in a minute. Yeah, and then 270 degrees.
-1.
Yeah, so for this one it will be -1. And then 360 degrees is back to 0, right? So that's going to go back to 0. So the way that I remember it is, at least the ones that are between 0 and 90, I just write this out like this: the square root of something, right, over 2, the square root of something 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 over 2, like this. These are like the 5 fundamental angles, right? And what I do is 0, 1, 2, 3, 4. That's what I do. Like just 0, 1, 2, 3, and 4, like that. And so the square root of 0 here will be 0. 0 divided by 2 will be 0. The square root of 1 here will be 1, and 1 over 2 is just 1/2. The next one is radical 2 over 2. Sometimes that guy is also expressed as 1 over radical 2, but we rationalize that. The next one will be radical 3 over 2, which we can't do anything about. The last one is 1 because radical 4 is 2, and 2 divided by 2 will be 1. But 180 for that one, 180, that's just going to be 0. Sine of 0, 180, 360, any multiple of 180, it will be 0, right? But just remember that 270 will be -1. And if you are thinking about the unit circle, right, I'm going to erase this, but for now, think about it like this. Say this is the unit circle that we have, right? Yeah. If you are a point here or here at any either endpoints like this, what will be the value, the y value for these points right here? The y values here are 0. And what are the y values representing? The y values are representing sine. So what is theta equal to at the positive x-axis? Theta here is 0. What is theta equal to in the other side of the x-axis, right? Yeah, this is going to be 180 degrees, right? What will be the value of theta right in the middle? Yeah, pi over 2, or let me just put 90 degrees, right? But do you see that whether you are at 0, 180, 360, right, or keep on adding it, sine is going to be 0. What is the value of sine up there? up there at 90 degrees. The value of sine there, 1, right? Because that's the y value of the coordinate. What about down here? What will be sine theta there? Negative. So that's where we are right now. So 180 will be 0. 270, that's the one on the bottom. That's going to be -1. And 360 is back to the beginning, right? But again, I think the most important ones are the first 5 of them. The last ones we can easily look at later on at the reference angle, and we're gonna get one of these fundamental angles as well. But we still have to figure it out the cosine, right? So let me get this out. Cosine. So for cosine theta, how are we gonna get the values for cosine theta? Yeah, they run opposite to each other. We call sine and cosine complementary angles. So meaning that, let's focus on these ones, right? I'm going to highlight this, just this part right here. I'm just going to highlight this part. There you go. And I'm looking at that. So cosine and sine, they are going to run like this. So I'm going to start from the last one. So this one, the one before that, sine theta ended at 1. So this is going to start at 1. And then the next one is going to be radical 3 over 2. Then radical 2 over 2, they meet there. Then 1/2. And then finally 0. Yeah, they just run opposite to each other. What about the last one? What is cosine of 180 degrees? Yeah, -1. Yeah, -1. And then what about cosine of 270 degrees? 0. And then 360 degrees? 1, because it's back to 0, right? Yeah. But we still have to add the tangent. Let's add these. Tangent, and then the other ones, right? There are a total of 6 of them, right? Let's see. And it would be nice if you can remember them, because you don't have any reference sheet or anything, right? And if they ask you anything, they will just ask you for specific angles, and you get the idea for that. So what about tangent for this? Tangent, we define tangent as sine over cosine. So we have sine and cosine, all we have to do is divide them. So the first one will be 0 over 1, which is 0. And then the next one will be 1/2 over radical 3 over 2, right? 1/2 divided by radical 3 over 2. So that's going to be 1 over radical 3, but you have to rationalize it, right? Yeah, radical 3 over 3. 45 degrees, well, these are equal, right? Radical 2 over 2 divided by radical 2 over 2, that's just going to be 1. So tangent of 45 degrees will be 1. What about 60 degrees?
Radical 3.
Yeah, so radical 3 over 2 divided by 1/2, that's just going to be radical 3. Okay. The next one will be 1 over 0. What does that mean? Undefined. What do you think that will mean for the tangent graph? The vertical. Yeah, so this will be undefined. And what we mean undefined is that we should think about this as a limiting value. It will depend on which side are you coming from. And undefined just means that you are at infinity, but you could be in either infinity, positive infinity or negative infinity, right? Depending on that, how you're approaching 90 degrees. What about 180 degrees? That's going to be 0 over -1, but it's still going to be 0. The other one will be -1 over 0, so that's going to be, undefined. And what about 360? That's going to be 0 over 1, which is 0, right? Yeah. But that's how we're getting tangent. We're just taking the ratio of sine over cosine.
30 degrees.
Uh-huh.
How do you get radical 3 over 3?
Yeah. So you when you simplify that, right? When you simplify this, you're going to get 1 over radical 3, right? When you simplify the left side, the 2's will cancel out, right? And you get 1 over radical 3. What do you do to this one? You have to rationalize it, right? So you multiply this by radical 3 over radical 3. What are you going to get on the bottom?
Radical 3 over, instead of radical on the left, so
Mm-hmm. Yeah, but we get that on the right side, yeah. But you just have to rationalize the answers, yeah. Yeah. So the next one will be the other three, right? So let's see if we can do this a little bit faster, right? So 1, 2, and the last one here. Yeah, and let me complete this. There we go. Okay, so what about the next one? Let's start with cosecant. Cosecant is defined as the reciprocal of sine. So it will be whatever sine is, right? But the reciprocal of it. So the first one is 0. So what do you think cosecant is going to be?
0.
No, the reciprocal.
Undefined.
Undefined, yeah. So this is going to be so 1 over 0, which is undefined. Undefined. UND. What about cosecant of 30 degrees? 2 over 1, right? So this guy is going to be 2. What about the next one? Yeah, or is just going to be 2 over radical 2, which is just going to be radical 2 when you rationalize it. Then the next one is going to be 2 over radical 3, but you have to rationalize it, and it's just going to be 2 radical 3 over 3. The next one is just going to be 1. Then the next one is going to be so 1 over 0, which is undefined. Then negative 1, and then finally undefined. What about secant of theta? This is going to be the reciprocal of cosines, right? So this guy is going to be 1, then 2 over radical 3, which is just going to rationalize to 2 radical 3 over 3. Then 2 over radical 2, which is just radical 2. Then this is going to be 2, and the next one will be undefined. Then what about 180 degrees? This is going to be negative 1, right? At 270? Undefined. And then at 360 degrees is back to 1. And then finally the cotangent one. What is cotangent theta going to be equal to? So this guy is going to be so cosine over sine, or the reciprocals of tangents, right? So the reciprocals of tangents. So this guy is going to be 1 over 0, which is undefined. Then the reciprocal of tangent here is going to be 3 over radical 3, right? Which is just radical 3. The next one is 1. Then this one is going to be 1 over radical 3, which is just radical 3 over 3. The next one was 1 over 0. This guy is going to be 0 over 1, which is 0. 0. And what about the other one? This guy is just going to be negative 1 over 0, which is undefined. The reciprocals of tangent, right? Then the next one is 0 over negative 1, which is 0. And the last one is undefined. 1 over 0. But this is the table that we have. So if they ask you, hey, what is tangent of 45 degrees, so you should know that that's equal to 1, right? Automatically, right? It's like you really want to be sure that you remember this. They don't give you a reference like paper in exams, and that's what you're expected to remember.
But this only works with the unit circle, or does this work across the board?
It works across the board, but we have to get a little bit familiar with reference angle in the next section, where what if you want to calculate sine of 135 degrees? Then you are going to look at the reference angle of 135 degrees, right? And then say that's 45 degrees. And then if you know what sine of 45 degrees is, then you know what sine of 135 degrees is. Something like that. So you will expand this, but this is the fundamental angles that we're supposed to just remember. So here is a question, right? Because we don't have we don't have a calculator, or we are not used to we are not allowed to have a calculator. Let's evaluate this, right? Here's an example. Evaluate A. What is sine of pi over 6 plus cosine of pi over 6. What is that equal to? Sine of pi over 6. Yeah, so that's going to be 1/2 plus, and then cosine of pi over 6. Yeah, so that's going to be radical 3 over 2. That's from the table. That, again, you have to take a look at the table. Right?
Wouldn't it be easier just to do radical 1, 2, 3, 4, 4, 3, 2, 1 all divided by 2?
To get this one.
Just to memorize that.
Yeah, sure, yeah. But again, like I see this and I don't have the table in my head. I don't. It's just that you see it again and you just recognize it, right? And it's not that I see this every day. I haven't looked at this in a long time. Yeah. So what is this guy going to be? That's just going to be 1 plus radical 3 over 2, like that. But we get that. What about this one right here, b? What would be, say, sine of pi over 4, right, plus cosine of pi over 2, all of these squared, to evaluate this guy. So what is sine of pi over 4?
Square root of 2.
Yeah, so sine of pi, yeah, so it is going to be, sine of pi over 4 is radical 2 over 2. Yeah, radical 2 over 2. And again, you can take a look at the table for y. And what is cosine of pi over 2? Cosine of pi over 2 from the table is 0. And then all of these squared. So that's just going to be radical 2 over 2 squared. And what? Yeah, that's just going to give you 1/2, yeah, when you simplify this out. Right. But this is all coming from the table. It's like, we're supposed to know what these are. Yeah.
I can square the bottom as well, or just the top?
Yeah, we square both of them. Yeah. So the square root of 2 squared, that's just going to be 2 on the top, and the bottom is 4, so that's going to reduce to 1/2. Yeah. Here's another one, right? C. Say we want to know what cosine of, let's put pi is divided by 1 minus sine squared of pi over 6 is equal to cosine of pi. What was pi in degrees? 180. So if you're taking a look at the table, that's pi over there, right? What is cosine of that? -1. So this will be -1 divided by, right? And 1 minus whatever this guy is squared. What is sine of pi over 6? Yeah, 1/2. And 1/2 squared is? So we have -1 on top, 1 minus 1/4. So we have -1 on top, and on the bottom we have 3/4. And what is this going to equal to?
4/3,
Yeah, -4 over 3. Right. Definitely more simplification right there. But hopefully it makes sense. There are other things like this one, for example. Like, take a look at this. D. See, what if I ask you to compute what is sine of, and I don't want to put degrees, right? But it's fine, right? So what will be sine of pi over 3, right, times cosine of pi over 6 minus tangent squared of pi over 4, like that. So to see if you remember what they are. Sine of pi over 3 is 60 degrees. Sine of 60 degrees is, so you radical 3 over 2 times cosine of pi over 6. Pi over 6 is 30 degrees. Cosine of 30 degrees will also be radical 3 over 2 minus, and tangent squared, right, of pi over 4. Tangent of pi over 4 is 1. So this guy is 1. So 1 squared is 1. So we're going to have this 3 divided by 4 minus 1. So 3/4 minus 1, what is that going to be? Yeah, negative 1/4, right? But definitely a lot of simplification that is done, but you need to know what the values of these guys are for you to simplify them out, right? You need to know that. That's like really important, yeah, to know. Here's one more, right? What is cosine squared, right? And for this one, I'm going to write an identity later on, right? That you might encounter it. What is cosine squared of pi over 6 minus sine squared of pi over 6?
1.
Let's see, right? If it was plus, they will add up to 1, but there's a minus in between them.
0.
But let's see, right? Yeah. So we understand that if it was plus, they will add up to 1 because of the identity that we just came from, right? But again, that identity is not studied in 190; it's studied in 195 more, and you get like many other identities in 195. So cosine squared of pi over 6 minus sine squared of pi over 6. Cosine squared of pi over 6. What is cosine of pi over 6? Radical 3 over 2. Yeah. Pi over 6 is 30 degrees. Cosine of pi over 6 will be cosine of 30 degrees, which is radical 3 over 2. Squared minus, yeah, and this guy is going to be 1/2. So we're going to have 3 over 4 minus 1 over 4. And all of these is just going to be, yeah, 2 over 4, which is 1/2. That's what this guy is. So the identity for this one is this one, right? But again, you're not supposed to like remember this, not until you go to 195, unless the book says it, right? Here. So there is an identity that looks like this. Like we say that cosine squared of theta minus sine squared of theta will equal to sine 2 theta. Yeah. You don't know which one identity is. It's so many of them. Yeah. Yeah. So imagine you do this, right? For example, if again, I'm not telling you have to remember. You don't have to remember. I'm being honest. You don't have to remember for this, right? We're not concerned with these identities. But you hopefully have experienced what this looks like. Later on, you have to understand why, where does it come from, and most importantly, when do we use it. So we're trying to evaluate cosine squared of pi over 6, right? Minus sine squared of pi over 6. So this is going to be sine of 2 times pi over 6. So that's going to be sine of pi over 3. What is sine of pi over 3? Yeah, pi over 3 is, let's see, did I get this?
Yeah, no, that's cosine.
No, yeah, so I think I messed up here. Yeah, cosine, sorry, yeah, I messed up here. This is supposed to be cosine here. Yeah, cosine, there you go. That will work, cosine. Cosine. That will work. Okay, so cosine squared theta minus sine squared theta equals cosine squared of 2 theta. So let's plug this into what we have here, and cosine of pi over 3 will be 1/2. Yeah. So that will work out there. But again, the identities will come out later in our book, right? I'll come back to this one in a minute. In our syllabus, we have this, right? Let's see. Yeah, this one right here. So math 190, the syllabus. Oh, come on. Yeah, this one right here. The syllabus will look like this. This is where we are right now in 6.2. The next thing will be 6.3. In 6.3, we're going to talk about trigonometric functions and the angles between them. And this is where we're going to define what a reference angle is. And are we going to learn like fancy formulas? We're not. We're just going to learn three formulas, and they're all going to come from these formula here. These formula here. The cosine squared plus sine squared equals 1. They're going to be derived from there. We call them the Pythagorean's triples formulas for trigonometry. But we're not how to memorize these things, right? I can list them at the end if you want me to, but it's not what we are supposed. They're going to study this in pre-calculus 195. But here's another question, another example. Here. Example. So suppose that a 20 feet long ladder leans against a building so that the angle between the ground and the ladder is, say, 23 degrees, right? How far is right? Let's see. Yeah, how high does how high is better? Does the ladder reach on the building? Suppose that you have a building like this, and this is the, I guess, the road or the ground, and here is your ladder like this. Let's make this a little bit bigger. There. And this is the building here. This is the road or the ground. So what is this angle here that they gave you? The angle of 23 degrees. What is that? Between the ground and the ladder. So that's going to be this guy here, right? And let's call that theta. Theta is going to be 23 degrees. They didn't give it to you in radians. They could have, but they chose to be this. Is this going to be forming a 90 degree angle here? 90 degree angle there. And how high, right? How high does the ladder reach the building? So that's going to be this question right here, right? What is this guy here? Yeah, let's call it H, right? Yeah, let's call it H, right? Do you know how long the ladder is?
Yep.
Yeah.
What is that?
20.
20. So we want to know the opposite from the angle, right? The length. So instead of using cosine, we should use sine. If you use cosine, it will tell you how far on the ground the ladder is, right? The foot of the ladder is. So we're going to use sine of theta will equal to, right, opposite over hypotenuse. But opposite here is what we're calling it H. And this guy hypotenuse is 20. And what do you know about H then? When you
Equals 20 times the sine of theta.
Yep, 20 times the sine of theta. What is theta in this case?
23.
So 20 times sine of 23, and that's why we're gonna leave this on like this. We're not gonna evaluate this. By you plugging into a calculator, you're not telling me what it is. You're giving me an estimate of what it is. So mathematics is like, we make a big deal out of it, and it's like, that's not the answer. They will tell you that, like, that's not the answer. It's like it's a big deal. It's like, no, you're not telling me the answer. You're giving me an estimate of the answer. It's like, this is the answer. Yeah. So this is fine. If you don't have to evaluate sine of one of those angles that I told you, you leave it in terms of this. And in the final exam, what they do in the front sheet, they will tell you if you get sine of, like, I don't know, like 15, say sine of 23 degrees, like this one, right? They will tell you, leave it like that. Don't estimate it. You don't have a calculator to do that. Just leave it like that. But anyways, so for the homework, we're going to have section 6.2, and that's what you're going to be responsible of, to complete section 6.2. If you need to catch up with the homework, you should do so. And this is how the booklet is going to look like when for our next one, right? Yeah, so I put a face in it, right, to remind you, hey, you should do it, right? And it's going to be like it's going to be divided into sections, like the lines, right? Then inequalities, right? Then exponents, right, and so on by sections. And at the end of it, you should complete all of the 101 problems on it at the very end, right? Yeah. No, we're gonna get this next week on Monday. So this week we're gonna complete the booklet, and on the back of the booklet there are practice finals, right? Which I'm gonna ask you to submit by Monday, next Monday, right? And then on Monday when we have the test, after the test we're gonna give out these new booklets, and they're gonna be a lot thinner than this one. And then your goal is to complete that at the end of the week, right? I'll tell you instructions after that, right? On Monday, yeah. But you will have a week to complete it, and then after that we're gonna do just practices. Right?
So practices in the back of the homework. You're gonna look over them on Monday?
Yeah. So that's going to be completed over the weekend. Yeah. So if you started to do them, just save the answers, and you have to submit them on Monday. Yeah. But for now, tomorrow you have only one section due, which is section 6.2. Tomorrow we're going to cover section 6.3, and after that we just have two more sections, and that will be the end. We're going to start reviewing for that, right? Anyway, so where are you taking them, Annabelle? Rotunda? Yeah. Okay, that'll be great. Yeah. So let's see.